Have you ever been working in your electrical Revit project and trying to insert receptacles into walls and they just don't line up right, or the architect keeps moving the walls and your receptacles get placed in strange places? Or maybe you're still working with some CAD floor plans and you would like to have your Revit receptacles in there, but you don't want to have to draw in walls or reference planes or something to host those receptacles to. What you need is non-hosted receptacles, and I'm going to show you in this video exactly step by step how to do that. So stay tuned. So I'm in my Revit 2022. This is where I create my families for use in my 2022 template, and I can use that in any project 2022 or later. So I'm actually going to start a new family. So not a new model, but let's go down to new family. And depending on which version you're in, you may see some different kind of template structures, but I'm in family templates. And here in the US, I'm going English Imperial. And I want to go with a electrical fixture. Now, you can see that some of these are hosted. We have a ceiling-based or a wall-based. We're getting away from that. We want a standalone electrical fixture that is not hosted at all. So we're going to start with electrical fixture and go from there. So we're going to be creating a receptacle that has a back box and a faceplate. There'll be some graphics on the face of this for any 3D views you might do. It's nice to have a little bit of a graphics. We're not going to get crazy with it, but we want to have something on the front. And we want this to be vertically mounted, and we want to be able to specify how high it is. Now here's a picture of a real-life receptacle with a box, so you can see what we're after. You can also look at the receptacle family that comes with Revit and kind of model it after that. Because it was wall hosted, it's laying on its back and it's face up. We're not going to do that. We are going to look at this reference level as the top view. So we're looking down at the floor, we're looking at the top of the receptacle, and we're going to have it facing down so that when we hit front, we're going to see the front of that receptacle. So let me show you what I mean. Now, pretty much every family we create starts off with some kind of a box. And what we do is there's reference lines, which are 2-dimensional, and reference planes, which are 3-dimensional. They extend in all directions. So we are going to draw a reference plane, which will be the back of the box, because we're looking at the top. And we also want a plane that will be the front of the faceplate. Now this existing plane you see here horizontally is the center front and back. That is going to be the insertion plane, so the face of the box, and then the box will extend behind that. So you'll see what I mean here in a minute when I draw some more of this. But that's the back of the box. And then we want some planes for the left-hand side of the box and the right-hand side of the box. And then we'll just draw these in now. We want the sides of the cover plate as well. And we're just going to make that straight edged. In reality, they're kind of beveled. We're not going to worry about that. So we've got our box here, top of the box, and the faceplate is here. Now we want to dimension all of these, so we can vary them at will. If we have a deeper box, we can change that. So let's go ahead and add some dimensions, and then we're going to add some parameters to those dimensions as well. So we are just dimensioning the skeleton of this box. So let's see, let's go with from the front of the box to the back of the box. So we go up here, up top, you can find this align dimension, and then you click here first and go to the back of the box next, and then click anywhere off it. And then you can escape out of there, click on that dimension. So up here you can create a parameter. We don't have one made, so we need to create a parameter for that dimension. And we're going to just call it something descriptive like box depth. And we want this to be a type parameter so that we can have different types of receptacle that have different depths. And then dimensions is where that's going to group under the type parameters. When you open up the type family types, you will see it nicely arranged under dimensions. So there's the one we just created. But there is our box depth, and we can change the scale of this. This is just a display scale. It's not going to actually change any dimensions or anything. But if you change Right now we're at 1/2 inch. If we go to 1 inch equals a foot, it will make some of the text smaller. So that's the box depth. And then we have a box width that we want to deal with. So back to the dimensions. It's an aligned dimension, and we'll just go left to right. Doesn't really matter here, and click anywhere. And then on here, we want to create a parameter called box width. It's a type, and it's a dimension. This is the center, the vertical center running through our box, and we would like this box to be centered across this. So we need to add another dimension that controls the centering. So if we hit all 3 of these lines, click off here, there's a little EQ button. You hit that EQ button and it makes both of these dimensions equal, which in effect centers this box on this line. So that's the box itself. Now we could start drawing this box in as an extrusion, as a 3D element, but let's go ahead and establish a top and bottom for the box. So we need to go to the front view now. We're on a top view essentially now. And you can actually change this to say top view. And sometimes that's very helpful. And then when we do a 3D view, I like to rename this to 3D view. And that's only something that's happens here in this family editor. But let's go to the front view. And we can see our same reference planes that we drew in. They exist everywhere. And we can extend some of these down if we need to. In reality, these lines go on forever, but visually, we can control how far they are seen. All right, so here's our center line. And you can see right there, it's a center, left and right this time. Now, this horizontal line is at what's called the reference level. This is the level that is established to be the insertion level. When we bring this box into a model, this reference level will be its height. So do we want this to be the bottom of the box, the top of the box, or even the center of the box? It depends on what you're creating. Now, receptacles are typically measured to the center of the box. So we want the center to be this reference level. So we need a bottom of the box and the top of the box. So let's get those in there with reference planes. Now we're only dimensioning to reference planes. Again, that's our skeleton. We're not going to dimension to anything like geometry or solids. So let's just get the skeleton finished up. A lot of reference lines in some of these families. We want to dimension this as the box height. So let's get that in there. Click on that, create a new parameter, box height. Okay, so that's the box height. And then again, we want this centered along this horizontal plane. So dimension, hit the middle, keep going. And this one we want the EQ. Now, what do we get? Constraints are not satisfied. We've got orange lines. So something's going on with constraint, which means something's either locked or not locked or something. So if I say remove constraints, what happens? Well, it looks like what happens is this line got moved down below the reference level. We need to make sure that this reference plane is actually pinned to this reference level so it can't move around. So let's try that. Let's go to Align. Click on the reference level. We want to align it to the reference level and from there, and we're going to padlock it. So now, if I try to move this, I will get a constraints not satisfied, and I would have to remove the constraints. So this forces this horizontal line to be staying at the reference level, which is what we want. Now we can go ahead and create our box geometry. So go back to the top view. We're going to create a box right here using this as a skeleton. So go over to create, and you have a number of different solids you can create. An extrusion is a simple shape that's slid up, like extruded. A blend would be two different shapes, a bottom shape different than the top shape, and it blends into each other. And then you have revolves, which are for circular things, sweeps to follow a path, and then a swept blend is a combination of blend and sweep. So a lot of different things. And you can even do void forms, which are whole. You can drill holes into things or leave gaps in corners. So we're going to be simply doing an extrusion. You can draw this extrusion with different shapes. I can even use pick lines to pick these lines as our shape, but then I have to trim them. So I find that just drawing a box is sufficient. If I draw it exactly on top of the reference planes, Then when I click it, now I have an opportunity to padlock it. So see these little padlocks? I can padlock the sketch, because it's purple, the sketch of our extrusion to the skeleton of reference planes. So when I'm done with that, I can say, yes, I'm done sketching out of edit mode or sketch mode. And that created my extrusion. And then up here you can see the depth was 1 foot. I could have changed that, but I can easily change that now. It made it a 1 foot tall extrusion, and it started drawing on whatever this reference plane was that I'm drawing on. So let's go to the front view and see what happened. So the front view, we can see that the box started here at which was our reference level, and it went up 1 foot. I want this to extend from that line down to this line. So go ahead and hit the Align tool. I want to go to there, from there, and I want to lock it. I want to go, I'm still on the Align tool. I want to go to there and make sure I'm hitting the extrusion. I am. From there, and lock it. So now I've locked this extrusion to both all 4 sides in the top view and then the top and bottom in this view. So now I have my receptacle outlet box all drawn in. Now let's go to the 3D view and see what that looks like. Now this is showing me in this cube up here that I'm just doing a front view, and I can click a top corner of this to get a different view. So there I am with a orthographic view, and I can pick other corners, but this works for me. And this is going to be the face of my receptacle when I put a faceplate on it. So right now I just have a box. So let's go back to the top view. So now we want to draw the faceplate of this box. And we can also start to get this box a little more accurate. And we can look at a shop drawing or a cut sheet for a box to get this nailed down. But we're roughly going to be doing like a 2.5 inch wide by 4 inch tall box. So we're just going to put those rough dimensions for now. Because we made these parameters, we will be able to change these even in our model. So a depth will go about 2.5 inches. And box height, let's go with a 4 inch. And the width, let's go with 2.5. Now, let's put in 2 feet, 1/2 inch. So let's go 2.5 inches. There we go. That puts it more like what we're looking for. Now our faceplate looks a little thick. And again, we can play with the scale to deal with the letter sizes and even the thickness of this. So let's go ahead and change that scale maybe up to 6 inches. That gets really light. There we go. All right. Now this depth we want to be the faceplate depth. So let's go ahead and get a dimension and a parameter onto that. So I'd start here and go to there, because the second line you hit is the one that you want to move. I want the first line that I hit to stay where it is, and I want the other one to move in and out to get the proper depth. And then click anywhere, and let's make this the faceplate depth. Dimensions is good, it's a type. Okay. And then we also had drawn, these are pretty far out now, we had drawn some sides of this faceplate. We can bring those in. We want those to be a faceplate width. So these are going to end up being centered, so it doesn't matter which one I do first. Click it off here, and we're going to call this, set up a parameter. Lots of parameters. Faceplate width. And then we want to center that, and the way we do that is we click here, and then here, and then here. We can move this dimension anywhere we want, and hit the EQ, and there we go. Now, this center line has a pin in it already. Instead of a lock, it's actually a pin, so it's pinned to not move. And let's make that faceplate width, let's make it 3.5 inches. And then the depth, let's go with 1/8 of an inch. Nice and thin cover plate. Now we want to draw an extrusion for this cover plate, but we need a top and bottom before we do that. So let's look at that. So here we are. We want to change the scale of this view as well. There we go. We already had the width because we drew those lines in on our top view. So on the front view, we also want a top and bottom. Back to our create reference planes. Let's get one a top and a bottom. Get these all dimensioned. And we want to center this. So there, there, there. Click off here, hit the EQ. Now we have a constraint issue again. So we'll remove the constraints, and then I will go ahead and put the constraint back. Let's go ahead and align it. Zoom in so I can get to it. To there, from there, and lock it. So there's kind of a workaround we have to do to make this EQ work. And then the height of this, let's make this a 1/4 inch each, so 4.5. And it looks like we made our width a little too much. Let's go back and fix that. Instead of, we have, let's get these down here where we can see them. Instead of 2.5 for that, 2.5 for the box, and 3.5, let's just go 3 inch for the width. Yeah, a little more consistent. There we go. Okay, now we need to draw our faceplate. I'm going to do it from the top view. So we're going to draw an extrusion around here now for a faceplate. So create, extrusion. We're going to use our rectangle tool and go from this corner to this corner. And we have 4 little locks. This guy's way over here. To the left, top and bottom, lock, lock, and the right side right there. Finish it. Now it's only 1 foot tall, so we'll have to fix that. And 1 foot tall is pretty tall now. Let's get the bottom of this aligned with the bottom and lock it. And then align it to the top from there and lock it. Okay. Now in 3D, you can see, and let's change the scale of this as well. You can see we have a faceplate and we have a box. Now, we haven't rounded the edges or anything beautiful like that. This is just going to be a rough indication of a receptacle. You can get as fancy as you like, but this will do for our purposes. I would like to put a little design on the front of this, though, that is just what I call painted on using model lines, which will show up in 3D views to make it look like a receptacle rather than just a blank faceplate. Sometimes it's nice if you're trying to do some kind of an elevation or a rendering, even though it won't be, photographically realistic like an architect would do. So we can actually bring in an image. If you have a PDF or even just some kind of a JPEG or a PNG, you can bring that in to kind of draw over. So let's see how we do that. Import an image, and then it will not be visible in projects, and that's okay. And to improve performance, delete that image before saving the family. So just need to bring it in from wherever you have it stored. I just saved a screen clip of an image off of, like Home Depot's site or Hubble's site or something like that. And we'll just bring that in. And here it is, and it's pretty big. So I'm going to put it right here and then shrink it down. It looks like it scales pretty well. I got it pretty well, a little off, but it's close. And get this so that it's kind of centered. You can click on it and use your arrows and nudge it left and right and up and down a little bit. Arrow keys are nice for nudges. There we go. So that's what I'm looking at. I'm going to go ahead and draw this kind of detail. Now, one thing I should mention is that we're going to need to tell it where to draw this. So what I mean is, if you look at the top view, we want to draw it on the face of the faceplate. So we have to make sure we tell Revit we want to use the face of the faceplate. So one nice way to do that is to actually name this plane that is the face, and we can use that later. So click on it, and over here you'll see click to name it. And so I would say face of plate, just so we know it's not the face of the box. So now when I go to my front view and I go to create, because I'm going to create some model lines. Now again, model lines show up in the model. They're a 3D element. They are just lines, but they show up in a 3D view rather than a detail line. But before I do that, I want to say work plane. I want to set the work plane that I'm going to draw this on, because I could draw it on the side or the top, anywhere. So I want to set the work plane. I could pick a plane, and it's hard to pick a plane when you're looking at it, so I like to just use a name, and that's why I named it. Pick face of plate. There's my reference plane. Face of plate. Okay. We are going to draw this on the face of that plate. So let's go to model lines. Now it's a very symmetrical shape. So I'm going to draw one half of it, and it's even symmetrical top and bottom, the outside is. But we're going to do our best, and I don't need any reference planes or reference lines. I'm just going to draw this freehand to there. And then I want to copy this from here down to about here, and it's giving me lines on either side of this. And then this is going to be an arc. So let's go up to create, model line, and go to the arc tool. You can start end radius, or you can center and ends, or you can do a tangent. So I'm going to use the start end radius. So start, and it kind of snaps. You'll see it kind of snaps to the end point of this line and snaps to the end point. And then I can use this to get my radius. You can see I can kind of match it to the radius of that receptacle. What I also want to draw is the receptacle blade holes. Now they're a different size. Hot here, neutral is the longer one. If I draw the bigger one and copy it, then I can shrink it down. So let's just draw that. And I just, again, I'm just drawing on the face of this so that it's not a lot of 3D extrusions that have to be created in the model. If you have a lot of 3D objects and extrusions in here, and you repeat this receptacle, 300 times in your project, that's going to be a lot of processing power to draw that. So simple model lines are the way to go unless you really need a 3D element. So let's get it something like this. And then I need to do half of this little guy. Or instead of mirroring it, I could just draw the whole thing. I think it'll be simple enough to just draw the whole thing here. So let's go to model line, here to here. And a line from here up to here. And then we can actually just copy this from there to here. There's a lot of good snaps in Revit's drawing tools. And then back to create, model, arc, start, end, and arc it. That looks good to me. And then let's go ahead and mirror. Just hold Control down and pick the few pieces we would like to mirror. And we're going to use this existing line as an axis, so we can use the first mirror tool, pick axis, pick that axis, and there it mirrored it for us. And then we can go through this and kind of slide it down to give us our shorter blade, or the hot blade. There you go. Now, of course, we can just copy this down here. So let's circle all these pieces and hit copy. And we can copy from, let's say, from the top to the top. And we can even draw the screw. Let's go ahead and do that. Nice little added detail. Use the circle tool, get it centered, something like that. That's a little not centered with those, so I'm going to move it down just a little bit. Let's get that a little more centered. And we're getting pretty picky here. And then get this screw slot in there, from there to there. And that will look just fine. So there we go, looks pretty good. Let's make sure we drew it on the right face, hit the 3D view, and there it is. It's drawn in the right place. We've got that done. Now while we're thinking about it, let's go ahead and set that default elevation for this receptacle. And we also want to make this, we can call it the standard, because if you recall, in the out-of-the-box receptacle, they have a standard, they have an above the counter, and things like that. So this is going to be right now going to be our standard. So let's go up here to the family types and create a type called standard. And let's give that a default elevation of 1 space 6, which is 1 foot 6 inches. So it'll come in at that height. And we can also create one called above counter. So let's go here and create another type and call it counter. Now that one can come in at something like 3.5 feet, so 42 inches, or whatever your above counter height is. And that can be changed once it's in your project. A few more things we need to do. Most importantly, we need to get an electrical connector on this so that we can actually hook it up to a panel. We can circuit this thing. Let's go up to create, and right here, electrical connector. Now we don't typically add conduit connectors to outlet boxes. Maybe to a larger junction box or something like that where you want to show conduit, you can add it. Or if you actually need to show small conduits in your model, I know some detailers I work with contractors will sometimes get to that level of detail when they're trying to detail out an installation. But as engineers, designers, we don't typically model conduit less than like a 1.5 inch. So I'm not going to worry about it here. So I'm just going to do the electrical connection itself. Now where to put that, it really doesn't matter. So I'm going to make it about at the face of this box. And I can put it on the face plate. I'll put it on this back plate. So there we go. Well, first of all, this connection is kind of like a nested connection. It's nested into this family. So I can only get to these parameters of voltage and poles and load classification and load in this family. I want to be able to get to these in my model. So I need to associate these to be type parameters so that they show up in this type parameter list. So I call that also mapping, but they call it associating. So click on this electrical connector. And what I want to map or associate with my family type is, first of all, the voltage. So let's go voltage. I can move these around in the order later. Let's start with the voltage. So we don't have a parameter named voltage, so we're going to have to create one. So we're creating more parameters. Voltage, I like to have ultimate control over my voltage and phase for any receptacle I put in. Even though this symbol and the 3D is going to look like a duplex, I like to have ultimate control. It's a good practice to get into. So I'm going to leave it as a type. I want it grouped under the electrical heading. So there. And then I want the number of poles also in this tiny little box on the right. It says associate family parameter. We're going to create a parameter called poles. And it wants to put it under electrical engineering heading. I would like it under the electrical heading with the other ones. Okay. And then, very important on any kind of a load, this is considered a load, is make that system type, make it a balanced power system. As you can see in the unbalanced, it gave me separate lines for each phase of load. Say if I had a 2-pole receptacle, I don't want to have to break my load up and put it in as 2 pieces. I just want to have a single load of 2 kW on that receptacle or on that piece of equipment. I don't want to have to break it up. So I want it to be balanced. And I cover all of that in my video about electrical distribution in REVIT, which I'll link in the description below. So power balanced, that doesn't get mapped. That's just part of the family. But we do want to get the load classification so that you can make it a receptacle or make it other kinds of loads if you want, exterior receptacle or special receptacle, refrigerator, things like that. So we want to map this, and we're going to call this the same thing. We're going to call it load classification. So again, we're creating a family parameter to map this local parameter to. Under electrical, and then we want that load to be adjustable in the actual project. We will call this parent load, and let's get it under electrical. Okay. So we don't need to do the power factor lagging or the actual power factor itself. We're not going to be changing these in the field. This receptacle is always going to be like that. So there, we have those mapped. Now the last piece of this is I don't want to see this extrusion. This top view, I don't want to see this whole box and cover plate. In my plan view and my 2-dimensional drawings, I want it to look like a symbol, a receptacle symbol. It would be very tiny in an 1/8 inch view, so I don't want that. So what I need to do is, first of all, tell all of this extrusion stuff to not show up in a plan view. So if I go to 3D view, I can easily get to all of this stuff. That includes the model lines on the face. So I have all this 3D stuff picked, and I can make sure that's all I have picked by going here. Fixtures are the extrusions, and the lines are all of the receptacle faceplate stuff. Okay. And what I do over here is in Visibility Graphics Overrides, hit Edit. This lets you choose where you will see that 3D stuff. It will display, of course, in a 3D view. And do I want it to show up on the plan or reflected ceiling plan? So the two-dimensional plan views. No, uncheck it. Now, what about front or back, left or right? Well, in elevations and sections, yes, that's fine. I want those to show up. And then if I have different detail levels, I don't want those to show up in a coarse view. So I have control both on plan and on whether it's coarse or medium fine. So uncheck those two is how I like to do that. Now that those are done, we can get down to the symbol. Now, why don't I just draw the symbol right here? Well, because if I draw a symbol in here, it is going to get larger or smaller depending on the scale of my drawing. It's going to be actual dimensions. I want it annotative, such that no matter what scale my drawing is, 1/8 inch, 1/4 inch, 1/2 inch, I want that receptacle symbol to be an 1/8 inch diameter circle. So of course that's the difference between a symbol and an actual object. So I need to create a generic annotation. So let's go to File, and we're going to nest that into this one. So we want a new family and English Imperial. This time we're looking for an annotation. And you'll see most of these annotations are different tags. And so we just want a generic annotation, this guy right there. And that can be any kind of annotation, a symbol. Say OK. And it just gives you some notes. It says, change the family category if you need something different. We're fine with a generic annotation. Insertion point is at the intersection of these reference planes. OK. And then delete this note before using. We will do that right now. So we want our receptacle symbol that we can insert into our actual receptacle family. I use a circle hitting the wall with the two lines coming out. Some people let the two lines hit. I've seen it 50-50 pretty much either way. So we will do it this way for now. And I'm not going to be changing the size of this, so I don't need construction lines, reference lines and stuff dimensioned with skeleton, because I'm not going to be changing it. I'm going to draw it once and it's going to be done. So let's just go start creating lines. Let's go ahead and create a circular line. And I'm going to just do it at the center and then move it. And I want it a certain size. I want this to be an 1/8 of an inch diameter, so that means I want it to be 1/16 of an inch radius. So 1/16 of an inch. And there's a minimum size you can make. I think it's like a 32nd of an inch. So we're getting down to about the smallest you can do. I want the edge of this circle to be at this insertion point. So I can move it down by hand, and it's kind of moving all over the place. I can just move it and click on there and click right there. That'll move it exactly where I want it. And then I want the two lines to come down from it. Now, if you have a symbol you want to trace, you can always bring that in. I'm not going to be super picky on this. I'll just get close. Let's do this, and I want this to be about, it's just a symbol. It just has to be close. And let's go ahead and mirror this guy from that center line. I think that looks perfect. So let's go ahead and save this as a family. Save it in my ER folder. This is going to be ER symbol duplex annotation. And I'm only going to be using it in this family, so it's not something I'll bring into. Now, let me spell it right. I could bring it in as a symbol into a symbol list also, which is nice if you have these annotations made. Saved it. Now I can simply from here load it into my project, which is my other family, and close it all in one. So it just loaded it, and you can see I'm dragging it around. It's little. And so what I need to do is I need to put it right at my insertion point of my family, which is right here. So click on that. All right, so now I have a symbol. Let's go ahead and save this. ER, duplex, receptacle, NH, non-hosted, backup. One more thing we can do in this symbol is I would like it to also work for my above counter receptacle. Now, we typically use a filled-in center portion for above counter. Now, some people will fill in one side or do different kinds of things with a circle in it. But what I can do is I can go back to this symbol, and this is a little bonus lesson. We can fill this in and have that controlled with the visibility button. So let's go back to Edit Family. We're going to edit the symbol itself. Let's go in here. Now, what we're going to do is we're going to fill this in. Let me turn off thin lines. We're going to fill this in with what's called a filled region. It's kind of like a hatch in CAD. So a filled region, if you click on that, and it's going to be solid black, which is what we want, and then we need to sketch what we want the shape to be. Now we could use pick lines and start picking these things and trimming them and all that. That gets a little messy with circles and such. So I'm just going to start drawing. So I want to draw from here to here, and then from here to here, and then use my arc tool to just kind of draw over this arc. There we go. And arc from start to end, and pull it down so I can go clear down here. Let's just let it snap to there, and then I'm done. And you see it filled it in. Now, again, because of the scale of things, it makes it blobby, but you can go to the thin lines and see that's what it's going to look like. Now, I want to be able to control the visibility of this filled region. So what I have to do is be able to select it. Click on it. There I am. I've got the filled region selected. And over on the right, you see this graphics, whether it's visible or not. We can tie visibility of this center portion to a family parameter like we did other things. So if we go click on the far right, we're associating a family parameter, and it's going to be a yes or no family parameter to affect the visibility. So I don't have one, I need to make one. So let's just call this above counter. Because this is nested, it's going to be nested into another family. I need to do instance here, but I can make it a type parameter in the actual family. So that's a trick. Make it instance here because it's going to be nested. And I want this to be under graphics. Say OK. And OK. So now I've controlled the visibility of that center spot. So let's go ahead and load it into the project. And yes, let's save it. And you want to replace it? Yes. And then do I want to overwrite the existing? I do. So there it is. So now I have my above counter, and I can turn that off. And it's an instance parameter in this family. Now I need to map it again. I need to map this above counter because I'm nested a couple times. I need to make this above counter visibility a family parameter in my receptacle family. So I'm working my way up the ladder of associating and mapping. So yes, let's create that again and call this counter. And I want this to be a type parameter because I'm going to have a type called above counter receptacle. Like we already saw, it's going to have a certain height that it comes in. And let's put that under graphics. Okay. So now this family of receptacle has an above counter button. And for the counter one, I want it on by default. And in the standard, I want it off. So we're good there. Let's go ahead and save that. Start a new project to test this out. So we're going to go to a new project. I'm going to use my template. I have a video that I'll link in the description below for how to create your project template. So you have a specifically electrical project template. My ER folder, and there's my ER electrical template. Let's use that to create this project. Okay. And let's go to our first floor plan power. Now we don't have any walls or anything, so this will be a good test for this no-host receptacle. So let's go to receptacle. I didn't close it yet. I want to load it into my project and close it. So it does both. And here we are. I'm dragging the symbol around. And I can turn off the thin lines. Here's my symbol in my project. It's letting me place it anywhere I want. It's coming in at 1'6" for the standard. It does not need a wall to host. Click it there. You can put this in a CAD background type project, or you can put it in a REVIT project that you don't want this stuck to the wall. Maybe you have a pedestal receptacle that you want to show somewhere that doesn't have a wall, or you want to show one on the roof that doesn't have a wall on the roof next to a mechanical equipment. This is very handy. Let's test our above counter. So let's go down to our family and find it. Electrical fixtures, duplex receptacle. Now they had a GFCI, that's out of the box. We're going to do this one, then no hosted. Let's go to a counter. I could call it above counter, but we'll just call it counter. Come in here, put it right here. It's lined up, and it already has the center turned off, and I can't get to it from here. It's not an instance parameter, it's a type parameter, but it comes in at 3'6". Now if I change this one's 1'6". If I change it, just so you know, to the counter, it does not move it up. By changing the type, you can't change its mounting height, so you would have to manually change it. But if you enter it from here, it will come in. So that's something to keep in mind. But there we go. That is our receptacle. And if you want some more no-hosted families, I suggest you watch this video that's flashing on the screen now. It shows you how to make a non-hosted pendant suspended light fixture. So thanks for watching. Until next time.